So we're still in 5.2, and we're going to talk about the remainder theorem. Remainder theorem. If the polynomial f of x is divided by x minus c, then the remainder is f of c. The remainder is f of c. All right, so c is just a number. It's just a constant. Right? C is just a constant. So just a rinky-dink little proof here. So I put proof in quotations. If I have f of x, right, I'm saying x minus c, I'm dividing, all right, some quotient, okay, so I've got my divisor, x minus c, multiplied times my quotient, q of x, plus some remainder, okay? If I plug in c to my function, I get c minus c multiplied by q of c plus r. But c minus c is 0, and 0 times q minus c is just 0. So that tells me that f of c is equal to the remainder. Okay, how about that? So let's work a concrete example. Use the remainder theorem to find f of 2 given f of x equals x cubed minus 4x squared plus 5x plus 3. Plus 3. Okay? So, how do we use the remainder theorem? Well, look, guys. 2 right here is what I'm plugging in. Okay, so I'll look here and I see my remainder theorem, f of c. So my c here is equal to 2. Okay, so it's x minus c. So it's x minus c. Well, c is 2, so that's x minus 2. So I'm literally taking x cubed minus 4x squared plus 5x plus 3, and I'm dividing by x minus 2. The good thing about the remainder theorem here, like, we're kind of skipping a step when I say evaluate f of 2, okay? I'm automatically setting this equal to 0, solving for x and getting 2. So I already know what I'm putting in my box. That number here in the argument of f, that's what I put in my box right here. And I run through synthetic. There's a 1 in front of the x cubed, so that's 1. And then a minus 4 in front of the x squared. And then a 5 in front of the x and a 3 constant. So I run through and I drop down the 1, multiply 2 times 1, I get 2. And then 2 times negative 4 gets me negative 2. 2 plus negative 4 gets me negative 2. And then multiply gets you negative 4. And then add those, you get 1. And multiply, you get 2. And then add, and you get 5. So my remainder is 5. The constant is 1. The linear x term is negative 2. And then my x squared here. So my answer is x squared minus 2x plus 1 plus 5 over what? X minus 2. Well, look, I don't even have to write this answer out, because what am I trying to do? I'm trying to use the remainder theorem to find this value. Okay, the remainder theorem to find f of 2. F of 2, which is f of c, is equal to the remainder. So the only number that matters here when I work through this problem is my remainder. The remainder is 5. Therefore, f of 2 is equal to 5. And that's my answer. Now you might be thinking, well, golly, Mr. Clark, why don't I just graph f of x equals x cubed minus 4x squared plus 5x plus 3 in my calculator, and then I look at my table x equal to 2. And yeah, you can do that, but that's not what we're asking for. We're asking for you to use the remainder theorem to get this solution here, okay? Now, you might be saying, this is total waste of time. Well, maybe so, but maybe not if your job is to create an algorithm that is supposed to find solutions quicker. And you might think, where in the world would I do something like that? Computer programmers are working all the time to make your phone, make your internet quicker. And they do this through more efficient algorithms. It is more efficient for a computer to run through this, adding and subtracting, than it is to plug in numbers into an equation like this. It's a lot harder to plug in these numbers than it is to plug in those numbers. If you plug in these numbers, maybe it takes 0.002 seconds to solve. And with this one, maybe it takes 0.001 second to solve. And you might be saying, well, golly, 1,000th of a second. Well, if you do that operation 1 billion times, it really starts to add up. Okay, so it does make a difference between satellite internet and high-speed internet, right? Okay, which you might be learning right now. All right, so let's do, should we do another one? Yeah, I mean, I guess we could, whatever, right? We'll do one more. So let's use the remainder theorem, and we're going to calculate f of negative 4, okay? And we're going to be given f of x equals 3x cubed plus 4x squared minus 5x plus 3, okay? So how do I do this? Use the remainder theorem. Well, look, that negative 4, that's what I put in my box. 3, 4, negative 5, and 3. Drop down the 3 times negative 4. What is that? That's negative 12. Negative 12 and 4, that's negative 8. Negative, make a positive 32. What's that going to be? 27? Oh my gosh. 27 and negative 4. 27 and negative 4. Is that like 108? Let's see. Yeah. Okay. 108 negative. And so then when I add those together, I get negative 105. So what is the answer? F of negative 4 is equal to the remainder. What's the remainder? Negative 105. And that's it. Hopefully that will help you out with the remainder theorem, and you can knock that homework question out of the park. Okay, last part for section 5.2. So the factor theorem. The factor theorem. How does the factor theorem work? Let f of x be a polynomial. If f of c equals 0, then x minus c is a factor of f of x. Okay, we've already kind of talked about this, right? If x minus c is a factor of f of x, then f of c is 0. Okay, f of c is 0. Now, this is what I like to call in logic an if and only if conditional statement. So an if and only if. What does that mean? if it works one way, it's got to work both ways. So if I know that f of c is 0, then x minus c must be necessarily and sufficiently a factor of f of x. Has to be. Okay? So, here's an example. Solve the equation 2x cubed minus 3x squared minus 11x plus 6 equal to 0. Given that given that 3 is a 0 of f of x equal to 2x cubed minus 3x squared minus 11x plus 6. Okay? Now, if I know that 3 is a 0, that means that x minus 3 has to be a factor of this polynomial, which is really helpful because right now I'm not sure we could solve this. Okay, so we really need to have a factor. And so let's run through it with our synthetic division. Instead of doing long division, synthetic is definitely the way to go. Let's divide the polynomial by x minus 3. So let's do it. So x minus 3, so if I do 2x cubed minus 3x squared minus 11x plus 6, and I'm going to divide by x minus 3 because I know it's a fact. X equal to 3 is a 0. Okay, 3 is a 0 here. Then I know when I divide this, I'm going to get something doesn't have a remainder. So run through, set this equal to 0, x minus 3 equals 0, and then I get x equals 3. So I box up 3. So I put what? 2, negative 3, negative 11, and a 6. Drop down the 2. 2 times 3 is 6. Add together, get positive 3. 3 times 3 is 9. Add together, I get negative 2. 2 times 3, that's negative. Okay, so then that gets me 0, which is what I wanted for my remainder. If I didn't get 0 there and I was told it was a 0, then I done messed up. But I got it. So I got my number, my x, and my x squared. So what is this telling me? This tells me that my factoring, it becomes what? X minus 3 times what? 2x squared plus 3x minus 2. Where'd that come from? Right there. Okay. So, what am I going to do now? Well, I have a trinomial. I should be thinking t-chart. Okay, I think it's possible. So if I'm thinking t-chart, okay, I'm thinking AC method. Now, AC method, Angelina College, Austin Clark, patent is pending, right? So first times the last, 2 times negative 2 is negative 4. So I want it to multiply the negative 4 and I want it to add to 3. Okay, A times C. So is that possible? Yeah, I think so. 4 times negative 1, that adds to 3. Good. Okay, so this splits up to 2x squared plus 4x minus x minus 2. Grouping, it's 4 terms. Put a plus in the middle. What do you pull out? 2x. I can pull a 2x out of each one of those. What do I have left inside? I have an x plus 2. Excuse me. Here, to make this an x plus 2, I need to pull out a negative 1. If I pull out the negative 1, I have an x plus 2 left inside. Now I see I've got an x plus 2 and an x plus 2, so that comes out. And what is left? A 2x and then a minus 1, okay? But I also don't forget about this factor here. This is x minus 3. Now, this whole thing was equal to the original thing we had highlighted up here. And it's equal to 0. So I set this equal to 0. And what am I wanting? I'm wanting to solve the equation. That was the whole reason I did this, right? So the trick here with the factor theorem was, given the information that 3 was a 0, we came to this conclusion that when I did synthetic division, I would get a 0 here, and then I could get this factored form from here. Set each piece equal to 0 and solve for x. And hopefully we can solve each one of those three equations. X equals 3, x equals negative 2, and x equals 1/2. Okay? Those are the solutions. So the solution set is negative 2, 1/2, and 3. Close brackets. All right, we can do one more. Okay, same type of problem, and I have 15x cubed plus 14x squared minus 3x minus 2 equal to 0. Okay, I'm given that negative 1 is a 0. I'm given that negative 1 is a 0. Now, what does that mean? That means I can put negative 1 in my box and then write my coefficients. 15, 14, negative 3, negative 2. Okay? Draw a line, drop it down here. 15 and negative, that's negative 15. Add them, get a negative 1. Multiply, negative 1 and negative 1, make 1. Add them, negative 2, negative, negative, make a positive 2, gives me the 0, which is what I want. Constant, x, and x squared. So what is this telling me? This is telling me, look, if this is a 0, that means x is equal to negative 1, right? X equal to negative 1 is a solution. So if x equals negative 1 is a solution, then x, and then I add 1 to both sides, and what do I have it equal to? It's equal to 0. This is my factor right here. Okay, so we're kind of reverse engineering. All right. So this factors to what? So what is this? This is what I'm copying. Let's duplicate. Okay. So this factors to x plus 1 times what? 15x squared, what? Minus x minus 2, close parentheses. Now, will this factor? I think that it will. And you can run through the factorization here using the AC method. Multiply first and the last, I get negative 30. And then what do I want it to add to? I want it to add to this b term, negative 1. So if I do this, I think, what, negative 6 and 5. Okay, so negative 6 plus 5 gets me negative 1. So I could run through this, 15x squared minus 6x plus 5x minus 2. Group, make sure there's a plus in the middle. Factor out a 3x. I get 5x minus 2, then plus, and there's nothing in common between 5x and negative 2, so that's just a 1 pulled out when there's nothing there. And so this is going to factor, so it's going to be x plus 1 multiplied by what? 5x minus 2 times 3x. What's left? 3x plus 1. So set that equal to 0 and solve for x. That gives me x is equal to -1, x is equal to 2/5, and x is equal to -1/3. All right, guys. Hope this video helps.